Welcome to Educator.com. In today's lesson, we're going to be factoring trinomials with a leading coefficient of 1. We'll begin by talking about what we mean by a leading coefficient. If you have a trinomial in this form, x squared plus bx plus c, the coefficient of this first term, x squared, is referred to as the leading coefficient. Today's lesson applies only to situations where you have x squared, so the coefficient is 1. If the coefficient is something other than 1, then you need to use a different technique for factoring, and that's covered in the next lesson. So in today's lesson, we're focusing on trinomials in this form. And suppose that you factor that out into two binomials as shown. When you factor an expression in this form into this form, there are some interesting properties of P and Q. It turns out that the sum of P and Q equals B, and the product of P and Q equals C. And the reason this is important is that by knowing these two things and having this expression, you can figure out what P and Q are, and that allows you to factor such an expression. To illustrate, if I have x squared plus 6x plus 8, and I went ahead and factored that out, I would get x plus 2 times x plus 4. And in the examples, we're going to go over exactly how you get from here to here. For right now, I just want to show you what all of this means. So assume it's been factored out. That means that this is b, so b equals 6, c equals 8, and then I have p equals 2, and q equals 4. Okay, so what this is telling me is that b equals p plus q, and b is 6. So if b equals p plus q, and b equals 6, then p plus q must equal 6. And it turns out that is correct. So it equals p plus q, or 2 plus 4. So that checks out. Now let's look at the product. The product of p and q, p times q, is equal to c. So c equals pq. C equals 8, and p times q, so that would be equal to 2 times 4. That checks out. So by knowing this and knowing the expression, I can factor. I can find p and q. Okay, you also have to take into account the signs of the expression. In the first expression that we discussed, it was x squared in the form x squared plus bx plus c. If b is greater than 0, as shown, and c is greater than 0, then both p and q are positive. Both p and q are positive. So it would end up factoring out to this form. X plus p times x plus q. And if you think about it, remember that b equals p plus q, c equals p times q. Well, two positives are going to give you a positive. But you think, oh, p and q could be negative, because two negatives will give you a positive. That's true. However, I also need for the sum to be positive. And the sum of two negative numbers could not be positive. Therefore, the only possibility is that both p and q are positive. In the second case, for signs, I could have a situation where b is negative and c is positive. In this case, both p and q are negative. Let's think about why this is. Here I have b is negative, but c is positive. Well, a negative times a negative will give me a positive. That checks out. But in order for b to be negative, then I can't have two positive numbers here. So a positive times a positive would give me a positive, but then it wouldn't check out for the sum. The only way I'm going to get a product that is positive and a sum that is negative is by having p and q be negative numbers. Finally, I could have a situation where c is negative. Either it could be this, or it could be this. Either way, c is negative. The only way you're going to get a product that is negative, if c is negative, then you're going to have p and q be opposite signs, because if you have a positive and a negative, they will then come out to being a negative. So you need to memorize these rules, and that way when you look at a trinomial and you go to factor it, you go to work with it, you're going to know what signs P and Q need to be. Okay. We can use the techniques that we've just learned to solve equations. As in previous lessons, sometimes the first step to solving an equation is factoring. So if I'm given an expression such as this, I can factor it to this. Actually, not an expression, an equation. So I'm given an equation that is a trinomial with a leading coefficient of 1, and then I factor it into an equation in the form x plus p times x plus q equals 0. Now, recall the zero product property. The zero product property says that if I have the product of two terms and they equal 0, then either a equals 0 or b equals 0, or they have to both be 0. The only way you're going to get a product that is 0 is if one of these terms is 0. Therefore, if x plus p times x plus q equals 0, either x plus p equals 0, x plus q equals 0, or perhaps they're both 0. So you're going to solve for x for both of these and get two solutions. So in order to solve equations, you're going to use the zero product property. You can use factoring followed by the zero product property. For example, if I have x squared plus 9x plus 20, I could factor that to find this. And in just a minute, we'll be using some examples to show you how to arrive at this. And actually, not an expression, an equation. So if I have this equation, I could factor it out to x plus 4 times x plus 5 equals 0. So once I have this, I can simply say x plus 4 equals 0 and x plus 5 equals 0. Very easy to solve. And I have my two solutions. X equals -4 and -5. But my first step was going to be to factor. And that's what we're going to work on right now using the examples. Okay, so in the first example, I have x squared plus 11x plus 30. Now I need to think about how I'm going to approach this. First I look at this and I see I have the form x squared plus bx plus c. Since both b and c are greater than 0, I know that p and q are positive. Since p and q are positive, I'm going to end up with something in this form. Now, how do I figure out what p and q are? Here's where those two rules become very important. Recall that the sum of p and q is b. The product of p and q is c. Now let's look what I've got. I have, for here, this is x squared plus bx plus c. Therefore, b is 11 and c is 30. b is 11 and c is 30. So I looked at this and I said, okay, 11x, so that's bx, b is 11, plus c, that's 30. And I know that the sum of p and q are 11, and the product of p and q are 30. Knowing that, I can look at c and I can say, okay, I'm going to find the factors of c. So find the factors of c, which in this case, it's the factors of 30. Now just start out by finding those. I have 1 and 30. I have 2 and 15. I have 3 and 5. Excuse me, not 3 and 5. 5 and 6. 5 and 6. Okay, so 1 and 30, 2 and 15, 5 and 6. Now, any of these three would fit my criteria, p times q equals 30. However, they also need to meet the criteria where their sum is 11. So I'm going to also find their sum. And what I want, I'm going to put it in here, I want it to equal 11. I add 1 and 30, 31. That doesn't work. 2 and 15, 17. That doesn't work. 5 plus 6 is 11. Therefore, this is my correct P and Q. Because when I find their product, they equal C. When I find their sum, they equal B. So I know that this is my correct P and Q. So now that I know that P equals 5 and Q equals 6, I can go ahead and factor this. So looking at the trinomial that I was given, x squared plus 11x plus 30 equals x plus 5 times x plus 6. I can always use FOIL to check. I'm going to multiply my first terms, and that's going to give me x squared. My outer terms, 6x. Inner terms, 5x. Last terms, 30. Simplify to get my original expression back. So again, we approached this by looking at it and saying, okay, B is 11, C is 30. The sum of P and Q must be 11, and the product must be 30. The other thing I looked at was the signs, and I said both B and C are greater than 0, so P and Q are positive. So I knew I had this form. Then I went ahead and factored out C to give me possibilities for P and Q. And I had a few possibilities, but when I took their sum, I found that the only one that fit, the only one that had a product of 30 and a sum of 11 is the combination 5 and 6. So I knew that those are my values for P and Q. X plus 5 times x plus 6. Okay, looking at a second example, taking the same approach. Looking at this one though, I first see that B in this case is actually less than 0 and C is greater than 0. So what this tells me is that P and Q are negative. This is going to factor into this form. X minus P times x minus Q. Okay, so I figured out my signs. It's the first thing I do. The second thing I do is determine what B and C are. And I find that I have B equals negative 10 and C equals 24. Remember that P times Q equals C. So here, P times Q equals 24, and that P plus Q equals B. So P plus Q equals negative 10. So I'm going to find factors of 24. Because P times Q is 24. And I'm keeping in mind that these are both going to be negative. P and Q are both going to be negative. So negative 1 and negative 24, that's a set of factors, both negative. Negative 2 and negative 12. And finally, negative 4 and negative 6. Now, my second criteria is to make sure that these factors also add up to negative 10. And I want the sum to be negative 10. So I know that all of these fit my criteria for C, being P times Q, but I don't know what the sums are. So I find the sum, negative 25. That's not correct. I want negative 10. Negative 2 and negative 12, that's negative 14, not correct. Negative 4 and negative 6, negative 10. So this is the correct set of values for P and Q. And I know that it's the correct set of values because the product is 24 and the sum is negative 10. That's the hard part. Now I just need to put it in the correct form. So putting it in factored form, y squared minus 10y plus 24 equals, I'm going to use this form, x minus 4, that's my p, times x minus 6 for q. Use FOIL to check. So if you want to check your work, use FOIL. The first two terms, actually, we were working with y, so let me just go ahead and change this to y right here. Same basic form, but we are working with y. So we're going to end up with y times y is y squared. Outer terms, negative 6y. The inner terms multiplied, negative 4y. And the last terms multiplied give me plus 24. Simplifying to y squared minus 10y plus 24. So again, factoring when the leading coefficient of a trinomial is 1 involves determining what b is, determining what c is, finding the factors of c, and then finding values that have a sum equal to b. So find factors of c that have a sum equal to b. And you also need to look at the signs to determine how you want, what format your answer is going to be in. Okay. In our third example, I'm looking at this, and at first it doesn't look like it's in the form with a leading coefficient of 1. However, it's always smart to put things into the form you need them in or into standard form. So I'm looking at this, and I just need to switch around some of the terms. Standard form would be x squared plus bx plus c. So I want my squared variable first, then 5z minus 36. So I'm looking at this, and I see that I have c is less than 0. So when c is less than 0, p and q have opposite signs. One's going to be positive, one is going to be negative. Okay, remember, figure out the signs. Then determine what b and c are. b is equal to 5, and c is equal to negative 36. Okay, and this is going to end up in the form, the general form, x plus p, x minus q, where there's opposite signs for p and q. Okay, I'm remembering my rules that p times q equals c, and here it equals negative 36. And my other rule, p plus q equals b, which equals 5. So now I have to make my list. Factors of negative 36. Now certainly you may have to make a fairly long list when you're working with a large number, but there are also ways to make things quicker instead of just going through and writing out every single set of factors. I know that I want their sum to be 5. Therefore, it's not going to be two numbers that are very far apart. For example, if I took 1 and negative 36, they're going to have opposite signs, p and q have opposite signs. That's going to come out to negative 35. That's too far apart. So I'm going to go for something more towards the middle. We could start with, say, 3 and 12. 3 and negative 12. So if I have 3 and negative 12, 3 times negative 12 is negative 36. And when I find their sum, it's negative 9. And I want to try, if I tried the opposite combination, which I certainly could, I'm going to see that it's 9. This actually gives me another clue, because since I want a positive, I want the sum to be positive, I'm going to have the larger number of the two be positive. So that gives me another clue to help me do less work. Okay, so I think, all right, these aren't working. What's some more factors of 36? Well, 4 and 9. And I just said I want a sum that is positive, therefore the larger number will need to be positive. So I'm going to go ahead and try -4, 9. And when I add those up, they do add up to 5. So I've found my solution for P and Q, the correct numbers, and I did that by saying they're going to have a sum of 5 and a product of -36. That means they're going to have opposite signs. And I didn't spend time doing each factor. I just went for the ones that were reasonably close together so that they would give me a sum would be a fairly small number, like 5. And I found that -4 and 9 did meet that criteria. Okay, so going back and writing this again, I have z squared plus 5z minus 36. And I want to write that in factored form. And I know that my P could be -4 and Q equals 9, or I could certainly do it the other way. And that will give me x minus 4 times x plus 9. As always, you could check this by multiplying it out or using the FOIL method. So again, find B, find C, find the factors of C, and determine which one has a sum that equals B. And then go ahead and put it in your factored form. Use the P and the Q to put it in factored form. Okay, in the last example today, we have an equation. Therefore, our approach is going to be to factor and to use the zero product property. We're going to factor and then use the zero product property to solve this equation. In order to factor this and to then use the zero product property, I need to write this in standard form. Right now I have this, but standard form would be this. So I'm going to add 10w to both sides to give me w squared plus 10w minus 24 equals 0. So when it's equal to 0 and then I factor it out, I'm going to have a product that equals 0. Okay, using my usual approach, B is 10, C is -24. So I'm looking at the signs that I have here, and C is less than 0. So I already know that I'm going to have x plus P, x minus Q. I also know that the sum of P and Q is going to be 10. The product of P and Q is going to be -24. So I'm going to find factors of -24. And I want factors that will have a sum that is going to equal 10. Okay, so I know that P and Q have to have opposite signs, and that makes sense because P times Q is going to equal a negative number. And I could certainly start out with 1 and 24. But I look, and those are too far apart. That's going to give me -23. The other thing is I want 10 to be positive, so my larger number is going to need to have a positive sign. If I tried the opposite, I would just see that this is going to be 23. So I need to go with something closer together, with factors that are closer together. So I tried 2 and 12. I'm going to make the 2 a negative. When I add those together, I actually get 10. Okay? Now, if you aren't sure, quite sure on all the little tricks and shortcuts yet, that's fine. Make a complete list of the factors. Try each combination, -2 and 12, 12 and -2, until you hit the one that is correct. But as you go on, you're going to see shortcuts to where you can make your list shorter and really zero in on the best possibilities. But I did find what I needed, and that is -2 and 12. And I always just double check. -2 times 12 is -24. -2 plus 12 is 10. Okay, so this is now an equation. So we're going to have to do an extra step here to solve the equation. We're not just being asked to factor, we're actually needing to solve the equation. W squared, and this should say equals 0. Should say equals 0. Oh, actually I have that right here. Okay, so W squared plus 10W minus 24 equals 0. I can factor that, and I'm going to have x plus p, so x plus 12 times x minus 2. This is my p and q, equals 0. Now, use the 0 product property. Recall that that property says if a times b equals 0, then a equals 0 or b equals 0. What that tells me to do is set x plus 12 equal to 0 and x minus 2 equal to 0, and then solve for each of those. Okay, so this gives me x equals negative 12 and x equals 2. So I started out with this expression. These should actually be w's, but I changed my variable there, but same exact setup. So then I end up solving this out to find the solutions of x equals negative 12 or 2. Either one of those, if you could check it, you could put it in here. If I let x equal 2, I could substitute back here for the variable or here, and I would find out that my equation holds true. Okay, so when solving an equation such as this, the first step is to put it in the standard form, then factor. Once it's factor, use the 0 product property to solve to find the 2 solutions for the variable. Okay, thanks for visiting educator.com, and I will see you next lesson.